So, hi everyone. My name is Paak Quansah, and I just want to talk about deploying OpenTelemetry from proof of concept organizationally. So, pretty much the way we went about it, from prototyping it to actually deploying it at scale. So, before I get into that, just want to give a little bit of background on Pluto TV. So, Pluto TV is a leading free streaming service in America. We have thousands of hours of content within our streaming service. We're on 30 plus device platforms, and we have nearly 7 million daily monthly users. So just to give a little bit of idea of the scale on a business side, we're at about $1 billion in revenue, and then we're in more than 30 plus countries, so you can kind of get an idea of the scale that we're operating at. And go back. And just to give a comparison to other streaming services and how it stacks up, we're again at around almost 7 million monthly users, and you can kind of compare it to other streaming services, Netflix, Hulu, so on and so forth. So on the tech side, just to give you a little bit more of an idea of the scale that we're operating at, we have team members across 14 time zones, and we're ingesting a huge amount of log volume at a single instance. So I say all this to say, and just to give you a better picture of the scale that we're operating at, and I say all this to say, how do we gain insight to a system operating at this scale, right? So how are we checking its performance? How are we able to evaluate the system? So for our use case, we use observability. So observability gives us a peek into the system itself, and observability is usually associated with the three pillars: traces, metrics, and logs, but we want to use observability to get a peek into our system's performance without deploying any code changes. So you have so many observability tools to choose from. So in this vast observability landscape, how do you pick what's best for your specific use case? How do we show the benefits of having a single observability system organizationally? So we ran into a couple challenges when pondering that question. So we had existing observability tools that we're using, multiple observability tools that we're using throughout various teams to collect trace logs and metrics. We had various data formats that we were using to ingest that telemetry data, and different vendors and open source softwares. And on the other side, we had a consolidation problem. So when we have those vast amounts of services, how do we find the best way to onboard those services? How do we migrate those existing pipelines to a new up-and-coming observability pipeline? And how do we validate the data between the new one and the old one? And also, budget and vendor selection. So what's the best vendor or open source software for our specific use case? How do we evaluate that? So where do we begin? Where do we go from here? It's a question that we thought of when we were starting. So we decided to use OpenTelemetry. So OpenTelemetry is just a tool to generate and capture telemetry data from various sources. So it has a vendor agnostic implementation, so you can collect data from different sources such as Prometheus, StatsD, different protocols, and you can process that data and ship it off to, again, various either vendor or open source destinations. So the included components in OpenTelemetry are the APIs and SDKs, the OpenTelemetry collector, and of course the OTLP format to send different types of telemetry data. So the first thing that we, excuse me? Oh yeah, I'll just wait till I'm for questions. Okay. Yeah. So the first thing that we wanted to kind of touch upon was the data collection. So how do we collect data from these various sources? So we started OpenTelemetry as a side project. So we had various instrumentations that already existed. We had Prometheus and StatsD for metrics. We were using Zipkin B3 headers and W3 trace context for traces, and we were using OTLE logging format. So from these, we were able to instrument OpenTelemetry with different transports for Prometheus and StatsD for our trace headers, and also we were able to scrape the standard out for logs as they're being logged throughout the various services that we had in our system. So once we had the data collected, our second question was, how do we transport that data? So what's the best way to ship that data out to the various sources? So again, OpenTelemetry has three concepts. So it has the ability to receive data as the ability to process data that it receives, so you can mutate and modify attributes or different fields within the data, and you can export that data to various sources. And just to give you a better visualization of what that looks like, you can receive data from various sources, process it, and then export it to various sources. And you can instrument various receivers, processors, and exporters in one OpenTelemetry collector. So just focusing on specifically tracing, we started tracing without a service mesh. So without a service mesh, let's say we wanted to instrument our Go service. So we added OpenTelemetry instrumentation to our Go services. And due to that, the OpenTelemetry instrumentation was able to create trace ID and a span ID. So once we had that trace ID and span ID, if it didn't already exist, the following request, it would handle the trace header propagation. So once we ship that request off to the next service, that node service or whatever language you want to instrument had the OpenTelemetry instrumentation as well. So if the span ID already existed, it would become the parent span ID, and it would create a new span ID, and it would use the existing trace ID. So again, same concept, but with the Go service, so it doesn't really matter. So once you have all of those, that trace instrumentation for all your services, you can ship that off into the OpenTelemetry collector. So the OpenTelemetry collector will take all that data from your various sources, and you can choose to export it, again, into whatever source you choose. So OpenSearch, Elasticsearch, New Relic, Datadog, doesn't really matter. So we thought, okay, now that we have the tracing implementation down, how do we make it easier to propagate and handle tracing within our Kubernetes cluster? So we added Istio Service Mesh. So Istio is a tool that streamlines networking and observability amongst other things. For the observability portion, specifically tracing, it was able to handle the trace header creation and propagation from as a sidecar from each of the containers running in a pod. So just to give you a better idea, once a request comes into our service mesh, we use a gateway, and that gateway is able to add the trace headers that are required. Once we have those trace headers, it would then be sent to the Envoy proxy running as a sidecar to whatever container the request intends to go to. That Envoy proxy will handle sending the traces to the OpenTelemetry collector, as well as propagating the traces to the container itself. And so you can see, like before, instead of having the instrumentation within the Go service or the Node.js service, we can just have that instrumentation on a service mesh level. Now, on the service level itself, we still need to handle the trace header propagation, but we can send those. Can we wait till the end for questions? Yeah, so we
I just was wondering, like, the quality of the image is not clear. If it's a quick thing, you can fix. If not,
oh, yeah. Yeah, let me see.
sorry, I'm not sure if it's my eyes or everybody's.
Let me see if I.
I can read the screen. I think it's a font size issue, maybe.
Yeah. Oh, yeah, no worries. No, that didn't really help. Doesn't look like, I don't know how to, yeah. Oh, it's a projector itself? Oh.
I think that's the bad. Either way, that's like, if I go that way, it's bad. This is kind of okay, or it gets worse. Like that?
No, a little more
Right there.
color to you.
It's funny, I was looking at
Larger
Ingress
font,
Gateway.
it's easier to read, so if you can get the small font focus.
You tell me.
Okay, too much.
If you're trying to read the
Yeah.
trace IDs, don't
Not
even
too bad.
try. If you were like
Yeah,
of the slide.
yeah, but the resolution's already set, right? Is this better, or do you?
Just the size of it. Can you just scroll up the size of the content in the slide?
Let's see. I'm not sure how to do that. Like zoom in.
Yeah.
Yeah, I'm not sure how to do that within the slide itself.
It's all right.
It's okay.
Okay.
We can't go to that.
Alright.
I thought it was easier.
Where was I? Yeah, sorry about that, by the way. Yeah. All right, cool. Cool. So once we have the traces sent from the ingress gateway to the containers and the Envoy proxy running in those containers, we can send the traces. The Envoy proxy sends those traces to the OpenTelemetry collector, and again, OpenTelemetry collector ships it off into different sources. So once we have the data transportation down, the third thing that we thought about is how do we correlate that data with other telemetry data. So the first thing that we wanted to do was correlate our trace data with our existing log data. And for that, we were able to say, okay, all we had to do was add the trace headers, or span ID, trace ID to the logs itself, and we were able to correlate the trace data to the logging data. Now, we wanted to store and analyze the data once we were able to transport it. So what source or open source or vendor will we use to analyze and store that data? So we pondered a couple of things using OpenTelemetry. The first thing is open source solutions. So we use a variety of open source solutions. But for our use case, for our various sources of telemetry data, we decided to evaluate different vendors that we can possibly use. So during the vendor evaluation phase, OpenTelemetry helped us to do a couple of things to make the evaluation a little easier. We were able to compare multiple vendors at once without switching the instrumentation on a service level, so we only had to switch the instrumentation on the OpenTelemetry collector level. We were able to provide backwards compatibility, so if we decide we want to roll back to a different change, we were able to do that pretty easily. We were able to assess the vendors without any additional instrumentation to the service itself. So OpenTelemetry allows us to collect data from different protocols. So if we just wanted to evaluate a vendor that already has an existing statsd plugin, we can do that without having to instrument the service itself. And we were able to evaluate with real data. So real-time data that was coming in, we didn't have to mock any of the data that was coming in. We could use the real data that was already live. So I say all to say we evaluate different sources, and for our specific use case, we decided to go with Datadog for the scale that we're operating at and the visualization aspect. And due to that, we were able to get the trace data and log correlation from Datadog. That's kind of a big level picture of what it looks like. And so where are we at now? So before we were using a variety of sources, SignalFX, Grafana, OpenSearch to view logs and trace the metric data. So we took all that and we were able to congest it into Datadog into one source to make all that telemetry data viewable. So a couple lessons learned from going through that process. Account for potential setbacks and difficult questions. So this was a new frontier for us. We had observability, but not as it correlated to different types of telemetry data, and was very dysfunctional. So we had a couple setbacks, and we had difficult questions that that had to be answered as we were going through the process. We were able to adapt data pipelines as architecture continues to scale and evolve. So as you continue to scale your product, you always want to adapt the data pipelines to match your scale. Observability is just the first piece of the puzzle. So observability is just the first portion of it. Once you have that observability data in whatever source that you choose, you want to be able to monitor that data. You want to be able to set up alerts and actually analyze the data. Create and update and continuous update documentation. This was a big one because once you have this for other service teams to use, there's going to be constant questions, especially because it's new. If you have a running documentation page, it's easier to answer those questions, and it lowers your involvement in answering those questions. Develop and maintain demo services, and this is kind of correlates to the last one. So you want to show examples of how the instrumentation technology is working. So you want to be able to have services to showcase that. And pick your priorities based on impact. So this is also a very big one because when we first started, we were just trying to do everything, utilize all the tools that were in OpenTelemetry and all the features. But looking back, we should have prioritized what would have the biggest impact for all the service teams as a whole, and prioritize doing those features. So thank you for listening to my talk on OpenTelemetry. And any questions? Thank you. Yeah.
I didn't know what the abbreviation OLTP was.
Oh, excuse me?
What the abbreviation OLTP is?
Oh, OpenTelemetry Transportation,
OTLP.
OTLP, yeah. OpenTelemetry Transportation something protocol. I forgot what the L is, but yeah.
Or can you tell me what it is? Sorry.
Oh, it's just a protocol to transport telemetry data. So just like, STATC, HTTP, just a protocol to transport telemetry data, specifically that OpenTelemetry created. Yeah. Yeah.
How did the Datadog affect the business aspects of Pluto TV? What major changes in the business did it provide?
Yeah. So Datadog, and it could have been for any observability system, but Datadog helped correlate the data a little better. So when we had incidents, we had to pick from different data sources, vendors and open source softwares to kind of figure out what was going on, and we didn't have a good monitoring solution in place. So Datadog kind of helped us bring all that telemetry data into one place and have the correlation there, so we can see, okay, since our metrics dropped here, we can view the logs at that time and then see kind of what was going on. And then we're still scaling up on our monitoring solution, so creating monitors and SLOs for the telemetry data that's coming in, but that's kind of how Datadog helped us, with the instance itself.
So it's more for reliability versus a business objective?
Yes, more for reliability for our use case, yeah.
At the scale that you're at, I imagine sampling traces has to be part of the conversation. Is that something, what sampling rate are you using? Head-based, scale-based? Do you mind sharing a little?
Yeah, so we are starting to use head-based sampling. So we sample on the Istio mesh level. So Istio has this API, telemetry API that lets us set the sampling rate for the whole cluster. So depending on the environment, we'll sample lower environments, probably like 5%. The higher environments, I believe it's 70. So production environments, 70%. Yeah. So we deal with that on the mesh level. Yeah.
So Datadog has its own agents and collectors and so on. What advantage does OpenTelemetry have versus using that?
Yeah. So we wanted to make it agnostic of Datadog, just in case we just started using Datadog. It's a new relationship, but just in case we want to switch to something else, or let's say a service team comes with us with a good use case for using Grafana, right? If they're already using it, we wanted to kind of have that abstracted and not settle onto the Datadog agent. Now we do use the Datadog agent for telemetry data for now. We plan on migrating over to OpenTelemetry, but that's kind of the use case for us. Yeah, exactly. Yeah.
Are there any specific pain points of the integration of OpenTelemetry with Datadog?
I would say there's a lot of unknowns. Like since it's kind of like a new integration, there was a lot of lack of documentation of how to handle certain things, including like data ingestion, tagging on the logs itself. But those are some of the questions that we worked with as a team and with Datadog as well to answer and address those. So yeah, those were kind of some of the pain points. Yeah, you can go first. Yeah.
I saw that in one of the slides you had some legacy, like OpenSearch, that collects your logging. Is this a direct swap of your OpenTelemetry directly to Datadog and replacing, or is that still part of your pipeline?
As of now, we don't use any open source, so we did a migration where we sent the data both to OpenSearch and OpenTelemetry. Datadog. And once teams felt confident with using Datadog, more service teams were onboarded into Datadog. We scaled down on OpenSearch solution.
So your data is only available in Datadog. They're the ones collecting it. So then.
For trace and metrics, the data is only available in Datadog. Yeah. Mhm.
Do you have like a pre-production environment to test your metrics before you push them live? Secondly, if you don't have that, how do you ensure you don't get any regressions to the telemetry and monitoring when you make a change to that as it goes live?
Yeah, so we do have a pre-production environment that generates that service teams have that we can deploy up to, that we can see kind of how the metrics are being handled, and we can test that before we deploying the production environment. There are certain services that you don't get the, I would say, one-to-one data comparison with production due to some third-party restrictions, ads and all that. So we try to mock out those metrics as best as possible in our pre-production before we ship it off to production. But yeah, that's still kind of like a pain point for us.
There was the tracing window at Datadog with the lines going?
Let me just go back.
Now, yeah, go back. Went too far.
Oh, went too far?
Yeah, it was right before that. Yep, that one.
This one? Okay.
Where do you get, where is this data coming from?
Yeah, so this data right now is purely coming from the, two places. It's coming from the Istio proxy, or Istio itself, and it's coming from the service instrumentation on our Go services. I think service on Go, so our Go service and our Node.js service. So pretty much what it's doing is it's getting a request. The first request is going to a gateway. It's creating the request headers. Then Istio handles sending that request that request to the Istio proxy running as a sidecar in whatever container the request needs to go to, and then those traces are being sent to Datadog.
Which library do you use? Because with Datadog, there's a library. You got to import it and init or whatever.
So yeah, we use the OpenTelemetry instrumentation, so we don't use any Datadog instrumentation on our services. Yeah, and so there's still some work to be done. So right now you can see the trace name is OpenTelemetry client and OpenTelemetry server for like almost, oh, sorry, Bill, if you could see, yeah. You would see that it's OpenTelemetry client, OpenTelemetry server.
Names are there? Is that like the actual method?
So those aren't the actual function names, so we still have some work to get those function names into OpenTelemetry, kind of replace them. But yeah, that's still some work to be done. Let me get, you and then,
Do you have any statistics on how much faster you were able to teams were able to know what was causing the incident based on all this work that you've done? Like, is it a noticeable difference from all the previous tools that you use, and now you're consolidating into one dashboard? Like,
yeah, so you're pretty much just saying, do you have kind of before and after of how much it cost us for instance before versus now. The full Datadog integration is still ongoing. We're at a point where a lot of service teams are using, I think more than like 80% of service teams are using Datadog. I'm not sure the exact statistics, but from my personal experience on the incident channel, it's more responsive. We have a PagerDuty integration in place that alerts our knock faster. Based on the monitors and alerts that we set up. So in terms of numbers, like monetary number, I couldn't really tell you, but I could probably talk to somebody and get that number for you. Yeah.
One thing I've noticed when getting tracing started at companies is it's a big paradigm shift for devs who are super used to metrics and logs. Have you had trouble getting the developers to actually, have you done trainings, or how have you taught them about this new world and a new way of looking at the data?
Yeah, so we haven't done any like formal, trainings, but with the Istio mesh makes it a little easier because a lot of the tracing logic is abstracted for developers, so all they have to worry about is either sending child traces or trace propagation. So it's a little easier to start off with that, and then build out to database tracing with Kafka and things like that. So that's still work to be done on that front, but with the Istio service mesh, it makes it a little easier to onboard developers to the tracing.
A question on the metrics side. You now, like after this conversion, do you still use stats for collection, or are you like sending, or is it, how are you?
Yeah, so we use both StatsD and Prometheus for data collection. That's more of like a service team preference, whether they want to use StatsD or Prometheus or both in their services. We don't really tell them they can use one or the other. We just have standards for what can be sent to, what can be collected, and based on those standards, you can use whatever push-pull model you want to use. Yeah.
So like in custom metrics, let's say you have not had to change any like libraries at the application level for the teams that are using it, or did you have to change?
No. Well, yes and no. So they had to change, but not due to our change, our adoption of OpenTelemetry, but more so because we were moving from one vendor to another, and the way they handle certain metric data is a little different from SignalFX as opposed to the StatsD. I'm sorry, Datadog. And so they had to make some changes in terms of like using a counter instead of a gauge, right? Because the way they evaluate that on those two services or systems are different, but not because of our implementation of it.
I'm sorry.
Yeah.
Then there is like, is there like a parity between OpenTelemetry and StatsD that they interoperable?
Well, you can have a StatsD receiver on OpenTelemetry. So that's just, it receives StatsD data, and then it can ship it out to whatever source accepts, it has exporters to different sources. So based on data you collected, you could ship it out to, Datadog, whatever, SignalFX. And if SignalFX has, a receiver on their end, then it will be able to accept that data, that telemetry data.
What level of detail do you actually go down to the logging? I have like users that are at a level of like I want every network set. Does this do that sort of thing, or is it more high level sample metric?
Yeah, so more high level sample. You said for logging, correct? Yeah.
For all of it in general, I guess.
Yeah. So a lot. I think once we started kind of ramping up on observability itself, we had to like kind of take a step back and see what needs to be a log, what needs to be a trace, and what needs to be a metric. A lot of teams have, or not a lot, but some teams have, log messages that can easily be converted to a metric, and based on the metric, you can create monitors instead of having a log that says, okay, every single time it comes to, and doesn't really tell you that much how the system's performing. So more of like the standard of it and the evaluation of what needs to be what is kind of what we took into account.
You mentioned you have standards for your metrics. What are some of those standards, and what kind of guidelines do you give developers?
Yeah, so we just have attributes that need to be added, so service name, version, and environment. And based on those, those core standards, those are the required ones. We can kind of correlate the data from metrics to logs because they have this similar tagging for the attributes. We have some optional attributes that could be added, but those are the three main ones that enable telemetry data correlation throughout the whole system. Yeah.
I was wondering if you have products that emit, say, proprietary or emitted, logs or metrics or whatever that you wanted in OpenTelemetry, so you could get in an open standard way. How do you handle that type of conversion, or did you just leave it proprietary and say, I'll let Datadog figure it out or something? I don't know. Kind of
So when you say proprietary, do you mean?
No, I mean like, some developer wrote some code, like say from, and it's not using OpenTelemetry. It's its own, in my head, in the developer's head sort of way of doing things. And so you're like, oh, we could use that in OpenTelemetry because you want to like kind of
Okay.
Or do you just say, no, we'll just bring it in as is and
So we never ran into that issue.
both, or do you have both? Like, no, these they can convert it into OpenTelemetry, then some we could, or whatever it was.
Yeah, so we never ran into that issue, but we could. You know, if we had some piece of software like OpenTelemetry, since it's open source, we can add like different types of receivers, processors to OpenTelemetry itself to handle that. I guess the proprietary nature of what you want to collect and send to Datadog. But we never had to do that, but it's possible.
Well, I mean, like, for example, another example would be if there's software you purchase instead of you develop in-house, that you have no control over that, and they're not supporting OpenTelemetry.
Oh, I see. Yeah. So again, you depending on how the software accepts data. So let's say you want to send data to the software, you can create an exporter on OpenTelemetry, an exporter plugin on OpenTelemetry to send data to that software. But it kind of depends on how the two systems work. So if it's just like an API key or something that needs to be set, and then you can send on an endpoint to that software, then it's possible to add an exporter on OpenTelemetry. Yeah.
You mentioned Kafka, so that opens you up to retries and replays that you might need to do.
Mm-hmm.
Have you got any special considerations for telemetry due to handling separate retries or replays and the other handling separately?
Yeah, so we're literally just started our Kafka. That's good because the same question came up the other day too. We have a plan to handle that, like based on then I forgot which version of Kafka it is, but it has headers that could be added to a Kafka message. Based on those headers, we can have a trace header carrier, I would say, and that carrier can have the trace ID and span ID. So it kind of comes down to on every retry, do you want to create a new span ID? It's going to be part of the same trace, but do you want to create a new span ID or do you want to be a part of the span ID and just say, okay, this is just a continuation of the same span? So that's kind of like what we're pondering right now and like what route we want to go towards, but we don't have like a concrete answer for that. Yeah.
Could you have multiple IDs to track different contexts? Like, for example, you just want to get all the data for a specific service. You can log something with a specific ID, as it is still part of the whole like web trace. That one still has its own ID.
So you're saying in terms of correlating trace data to log data, you have one ID?
Yeah, can you use a different ID so that you can search on it? Although I guess
Yeah, you use trace ID, yeah, because if you have the trace ID on the trace portion of it, and you log it on the log message itself, Datadog has a tool that lets you view everything with the same trace ID in one place. But any vendor, if you have the trace ID on the log message itself, you can view all the data and pretty much like you can query for it yourself. Yeah.
Kind of really quickly talking about how you get this trace IDs into your log. I know you have a slide on it.
Oh yeah, that's just depending on what logger implementation you use, it's just adding it as an attribute field on the trace itself. Some vendors have a specific way you need to use it in order to view it all in one place, like for Datadog, for instance. But as long as you have the trace ID as a attribute on the metric itself and it's searchable, then that's really all. Depending on the log implementation, there's no real special way of doing it.
You didn't have to change any like service code to actually get it into their logs, or all this log.
Oh, so yeah, we did. Yeah, so we did have to. Well, so we did have to make a library to add those by default, right? So it just grabs the current context, gets the trace ID from that current context, and logs that. So the service team doesn't have to worry about logging in their own log message. But yeah, it needs to be manually done on the service itself.
Follow to that, you have to then transport the trace as part of the API between services.
Transport.
Like if you want to try to trace it from service A to service B,
Yeah.
you had to add in the service mesh do that for you, or you have to add in.
No, you have to add in the trace header propagation in the service itself. Yeah, even with this seal, you still have to do that.
Trying to find the line where what's provided and what's.
Yeah. It's a specific thing that has. So even well, you can't. I guess it's blurry, but like the picture, you can see that there's like a log field here, and you can view the logs that have the same trace ID for for pretty much in one place, and based on the trace that's set on the log itself. So that's just for Datadog implementation. Other services, other vendors have the same thing. Other vendors, you just query the trace ID once you get it, but it just depends. Yeah.
How long do you store? Like logs can be voluminous and cost a lot of money to store for a long time.
Mm-hmm.
A lot of it. How do you manage how much you store for how long?
Yeah. So we kind of worked out the data retention with the vendor itself, but we store logs for on Datadog. We store it for I believe 30 days, and then we have S3 bucket on AWS where we dump historical logs, and then that's I think data retention up to 6 months. So we can rehydrate those logs from the S3 bucket from a tool that Datadog has, and so that's kind of how we deal with the log storage.
Telemetry, amount of traffic you have, latency. So those longer, or want to say, how do I compare to last year?
Oh yeah, so metrics we don't store for more. Logs is the only thing that we store for a long period, past 3 months. Metrics I believe we store for three months, 90 days. Yeah. So we're working on getting a historical context for metrics, but logs is the only thing that we have long-term storage for. Yeah.
So Datadog turns over the logs to you and no longer has any proprietary ownership agreement or mandate against you. So you can effectively export all the fundamental data and keep it forever to do like seasonal analysis or things like that without using Datadog.
Yes. Mm-hmm. Yeah. Any other questions?
Do you have any cool success stories of someone found something using this system?
Success stories of.
Like someone who, using this, found a problem that they were dealing with? Or they don't have to be cool, I guess. Sometimes they're benign.
Yeah. I don't know. Yeah, I'm trying to think. I mean, there's one problem that we saw with tracing itself that we have. So let's say you had like one Kubernetes cluster and you had an incoming request. Instead of using the cluster level, I guess, DNS. So within Kubernetes, they were using the actual full URL name. So it was going outside the cluster and then coming back. The request was going outside the cluster and coming back in through the ingress gateway, which was inefficient. So we sold service teams like, okay, you need to change this to the actual, cluster level DNS instead of doing another round trip into the ingress gateway. That was one thing that we saw with tracing, but I'm sure somebody else has seen something from my team, but yeah, that's the only thing that I personally worked on. Yeah. Cool. Yeah. Thank you.